Bismillahirrahmanirrahim and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilham Abdul Nasir, and in this presentation, I'll walk you through my project titled Fire and Smoke Detection using Convolutional Neural Network (CNN) in MATLAB. This intelligent detection system was designed to enhance early warning, reduce false alarms, and improve safety in complex environments. Fire continues to pose a serious threat to both life and property across homes, workplaces, and industrial environments. Traditional detection systems, typically based on heat or smoke sensors, are often slow to respond and susceptible to false alarms. However, with recent advances in artificial intelligence and computer vision, we now have the ability to detect fire visually, enabling faster and more intelligent responses. In this project, we leverage deep learning using convolutional neural networks to automatically recognize fire and smoke patterns in both images and video streams. For problem statement, let's look at some common challenges with traditional fire detection systems. First, they often cause high false alarms, especially in areas with smoke, steam, or dust. Second, there's a delay in detection, as sensors usually react only after a fire grows large enough to trigger a response. Third, they are inaccurate in tropical or industrial settings where heat, humidity, and airborne particles can confuse basic detectors. Lastly, they struggle in complex environments like open spaces or densely equipped industrial areas. These limitations highlight the need for faster, smarter fire detection technologies. The main objective of this project is to design an advanced smoke and fire detection system with high accuracy and reliability, and by making use of best-in-class sensors, deep learning algorithms, and real-time information processing to reduce false alarms. The second is to improve security in residential and commercial buildings by overcoming the limitations of existing systems. Database description. For this project, we compiled a diverse dataset from multiple sources, including the Foggia Fire dataset, Kaggle, YouTube AM, and some synthetically generated images. The dataset is organized into three classes: fire, smoke, and non-fire. To prepare the data, we performed frame extraction from videos, followed by resizing and data augmentation to improve model generalization. In total, we worked with approximately 900 images. These were split into a training set with 630 images, a validation set with 180, and a test set with 90, following a 70-20-10 ratio distribution. The system was built entirely in MATLAB using the deep learning toolbox. A CNN was created using image input layer with convolutional layers. It was trained for 50 epochs with a learning rate of 0.001 using the Adam optimizer and a batch size of 16. We measured the model's accuracy, examined the confusion matrix, and calculated F1 scores to assess precision and recall across the fire, smoke, and non-fire classes. In this project, we followed an 8-step process to develop and evaluate our fire and smoke detection system using CNN in MATLAB. Step 1. We loaded the image dataset using image data store and shuffling it to ensure randomness. Step 2. We split the data into 70% training, 20% validation, and 10% training and resizing images using augmented image data store. Step 3. We built a custom CNN with convolutional layers, batch normalization, ReLU activation, max pooling, dropout, and a fully connected layer for classifying fire, smoke, and non-fire images. Step 4. Training settings included the Adam optimizer, learning rate of 0.001, batch size of 16, and 50 epochs using CPU execution. Step 5. The CNN was trained using the training data and the model was saved for the future predictions. Next, step 6, we evaluated the model on test data using accuracy, confusion matrix, and calculated precision, recall, and F1 score for each class. Step 7, the trained model was tested on static images, correctly predicting fire, smoke, or non-fire, and showing the predicted class with confidence. Lastly, step 8, we also ran a video demo classifying every 10 frame and visualizing the results using a prediction timeline and class frequency bar chart, simulating real-time detection. Result, accuracy and loss. During training, the CNN model demonstrated effective learning. Accuracy rose from around 25% in the first epoch to 98% by the 50th, showing strong pattern recognition. Validation accuracy also improved steadily, reaching 83.53%, indicating good generalization to new data. The training loss dropped sharply from 1.6 to 0.05, while validation loss decreased and stabilized around 0.4, suggesting no overfitting. Result, confusion matrix. As you can see, the confusion matrix confirms the model's strength. Fire and non-fire were classified accurately. Some smoke images were misclassified as fire, which is actually safer in practice. Discussion matrix. Moving on to discussion matrix, the fire class had a recall of 0.97, showing the model rarely misses real fire events. F1 scores fire 0.89, smoke 0.81, non-fire 0.94. The test accuracy have achieved around 88.24%. Discussion simulation. We tested the model on both static images and video sequences. For static images, it accurately classified fire, smoke and non-fire across different lighting and backgrounds. In video simulation, the model progressed each frame in real time and maintained high accuracy even as fire and smoke changed or moved. This shows its ability to handle dynamic environments, which is essential for real-world surveillance. Overall, the simulations confirm the model performs reliably across varied visual conditions and doesn't depend on static image patterns. In conclusion, our CNN-based fire and smoke detection system has proven to be robust, scalable, and accurate. It performs reliably even in challenging environments like tropical and industrial settings, addressing the key limitations of traditional systems. For future improvements, we plan to integrate temporal models such as long short-term memory networks, explore real-world deployment, and develop a user-friendly GUI interface to enhance accessibility and usability. It is now at the end of the video. I hope you have gained new knowledge and more experience in fire and smoke detection system for your future studies. Thank you very much for your time. That is all from me. Thank you and goodbye.